All right, so this is the second example of my Newton's law series. So let us get into it because I don't want to waste any time. This example is from one of the previous question papers, and we're going to do question 2. As you know that Newton's laws are in question 2, so we're going to do 2.1 until 2.6. So let us get into it. Question 2, it had said the diagram below shows a 10 kg block lying on a flat, rough horizontal surface of a table. The block is connected by a light inextensible string to a 2 kg block hanging over the side of the table. The string runs over a light frictional pulley. In the previous video, which is the first one, I explained the flat, rough, horizontal surface. I also explained the light inextensible string, and I also explained the light frictional pulley. But if I just had to quickly remind you of those concepts, then a rough horizontal surface, is the following. So we're going to have a horizontal surface, which is going to be from left to right. It's going to be like 180 degrees, right? So if it is rough like this, it simply means that there's a frictional force or the static frictional force, kinetic frictional force or static frictional force that is going to be acting on whatever object that is going to be on this surface. So that's what a rough horizontal surface means. It means that it forms 180 degrees. That is what the horizontal means. And the rough means that there's a kinetic frictional force or the static frictional force that is going to be acting on whatever object that is going to be on that surface. So that's what rough horizontal surface means. And a light inextensible string means the following. So we're going to have a pulley, of course. We're going to have a pulley like that, and of course we're going to have a table. And this block here is going to be connected to that pulley, and then there's going to be another block right there. Right, so what this light inextensible string mean is the following. The light part of it means that the string is massless. So it has no mass. It means it is 0 kilograms. At least that's what they're telling us to consider this string to be. And they're also telling us that it is inextensible. So it means that there is no elasticity force. There's no elasticity force. It means that when this object is pulled down, then it is going to pull that other object to the right. Then the whole system is going to move. But if this string was extensible, then when you pull this object down, then that object will remain at rest and the string would actually extend. Okay, so that is why they're saying that we should actually consider this string to be inextensible, so that we know that there's no elasticity force. I hope that is clear. Then they're also saying that the pulley is frictionless. So the reason they're saying that the pulley is frictionless is because they don't want the pulley to have an effect on the motion of the system. So if there was a frictional force here, of course the pulley would be rough. Then of course there was going to be a force, which is the frictional force, that was going to deny the motion of this string, and that was going to affect the motion of these two blocks. So they're just trying to say ignore all the effects of everything besides the system. So I hope that is clear. I've explained that in a previous video as well. Right, so let us continue. I'm going to erase this, so please just wait for a second. All right, so the other thing that I actually mentioned is the fact that the blocks are stationary. So what does the block stationary mean? So when you see the word stationary, that's a key word. It's going to give you clues on how to tackle the questions, right? So let us talk about this keyword stationary. The keyword stationary. Please do not mind my pencil. I actually like small pencils because they're so comfortable when I be writing with them than a long pencil, which is going to disrupt me. Anyway, the word stationary, which is a keyword here, it simply means that the system has no net force. It means the net force is equal to 0. And it also means that all forces are balanced or in equilibrium. So it means that all forces are balanced or in equilibrium. So let me actually shift my book a little bit to the left so that I may have enough space to write the equilibrium word. Equilibrium. So that's what the word stationary means. It means that the system is not accelerating. So acceleration is equal to 0, and of course there's no change in velocity. So velocity is also equal to 0. So it means that the system is not moving. It is not in motion. It also means that all forces are balanced or in equilibrium. This is the most important point of the stationary keyword. It means that the forces are balanced or in equilibrium. So we're going to utilize the fact that we know that when the objects are stationary, then the forces are in equilibrium or balanced. It means that all the vertical forces are balanced. It means that they're equal in magnitude but acting in opposite directions. That applies as well to the horizontal forces. It means that they're balanced, to they're equal in magnitude but they're acting in opposite directions. So that's what you gotta know. We gotta know that. Okay, let me write down that as a note. So we also know that vertical forces are equal in magnitude but act in opposite directions. That applies as well to the horizontal forces. So the horizontal forces are equal in magnitude but act in opposite directions. Right, so this is what the keyword stationary mean. It means that there's no net force, all forces are in equilibrium or balanced, and the vertical forces are equal in magnitude but acting opposite directions. So it means that the normal force is equal to weight, something like that, right? And the horizontal forces are equal in magnitude but act in opposite directions. That means the frictional force and maybe the tension, frictional force and the tension are equal in magnitude but act in opposite directions. So this is what the stationary mean, okay? So you have to take note of the keyword stationary. So as soon as you see the word stationary, this is the points that you gotta note before you get into the questions. These are going to give you the tools on how to tackle the questions that are going to follow. All right? Right, so let us get into the questions. Well, before we get into the questions, I want to draw this diagram so that I explain it better. All right, so let us draw this diagram. Of course, I'm not going to draw it beautifully or accurately. I'm not an artist. I'm just going to draw whatever that I see on this diagram here. So yeah, we have whatever. I'm not going to, oh well, let me actually draw it. It doesn't matter. And then we have this. And then we have this pulley. It is so funny because I actually have a friend called Pulley. Not Pulley, Pulley. So it really sounds like I'm actually saying her name when I say Pulley. Anyway, and we also have the 2 kg block. Yeah, right. So there's the diagram that we've been provided with, and of course they've told us that this is a table. I don't know how this table is not folding because it doesn't have another leg. That's funny. Anyway, this is what we have, right? So they're saying that the system is stationary or the 2 objects are stationary. So 2.1 says state Newton's first law in words. So when it comes to the laws or the definitions, I'm not going to explain too much about it because they are there in the exam guideline. So if you want to know much about the definitions or the laws, then you have to go to the exam guideline and refer to it and then study them, okay? But I'm going to assume that since we actually did this from grade 11, then we know what Newton's law states like. Okay, so this is what Newton's law states. Newton's first law, by the way. So Newton's first law, 2.1, it states that an object or a body will remain in a state of rest or motion at a constant velocity unless a non-zero force acts on it or unless it is acted upon by a net force. It depends on how you understand it or how you are used to saying it, right? So let us write that down. An object, some people are used to saying a body, it doesn't matter. An object will remain at rest or motion at uniform or constant. So uniform also means constant. Uniform or constant velocity unless it is acted upon by a net force. Some people call it a non-zero force, and some call it a resultant force. So this is how we state the Newton's first law. An object will remain in a state of rest or motion at a constant velocity or unless it is acted upon by a net force. Simple, right? So this is how we get our 2 marks. Let us go to 2.2. So 2.2 says, write down the magnitude of the net force acting on the 10 kg block. So we know that since we said that the object will remain at rest or motion at uniform velocity unless it is acted upon by a net force or a non-zero force, then what we know is the fact that have given us the stationary, which is the keyword, right? So we said that according to that keyword, the net force is equal to 0. So it means that the net force of the whole system is equal to 0. The net force on the 10 kg block is 0. The net force on the 2 kg block is 0. So they're asking about the net force on the 10 kg block. So it is equal to 0, obviously. So we're going to write 0. But we're not going to write the n, okay? So if you write 0 and you put n here, it is going to look like on. For example, look at this. When you do this, they're not even sure that you wrote 0 newtons. So this looks like on. So what you should do is put the n in brackets. This is only an exception for 0. But of course, for 1, it is going to be 1 newtons. 1 newton is not actually in, it's 1 newton. And also, I'm going to advise you to leave a space between the number and the unit, which is the newton, okay? So write 0 and then in brackets, write n. So they're going to be like, okay, this is 0 newtons. But if you write 0 and no bracket, they're going to assume that you have written on, okay? Right, so I hope that that is clear. So we're going to write 0 and in brackets, we're going to write n. So this simply means 0 newtons. So we're going to be like, or you can simply just say F net is equal to 0 and the same thing, because they asked for the net force. Right, so let us go to the next question. But before we get into 2.3, there's an information that I've been given, so let us read that information. So they're saying, before draw the free body diagram, when a 15 newtons force is applied vertically downwards on the 2 kg block, the 10 kg block accelerates to the right at 1.2 meters per second squared. So this is what they're saying. They're saying that there's going to be a force that is going to pull the 2 kg block down. There's going to be a force that's going to pull the 2 kg block down, and that force is 15 newton in magnitude. Right, so when this force pulls the 2 kg block down, there's somebody that's going to pull this block down. What's going to happen is the 10 kg block is going to accelerate to the right. Why is that the case? It is because according to Newton's second law, when a net force is applied to an object, the object will accelerate in the direction of the net force at an acceleration that is directly proportional to the net force but inversely proportional to the mass of the object. So what's going to happen is when we apply a force, a downward force, then we're going to have a net force that is going to be acting downwards to the 2 kg block. However, that net force is going to cause, because we have an inextensible string, and inextensible string means that when you pull this block, it's going to move down. That means the whole system is going to move. When one block is pulled, then that one is also going to move. because it's a system and they all move at the same time and all together, okay? So when the 2 kg block is pulled down, then it's going to move down. But the 10 kg block is also going to be pulled to the right. So since this is the net force that's going to be pulling the 2 kg block down, then this 2 kg block is going to accelerate it downwards, because according to Newton's second law, then when you apply a net force, that block is going to accelerate in the direction of the net force. So it means 2 kg block is going to accelerate in the direction of the net force, which is down. So it's going to accelerate down. But that is also going to cause the 10 kg block to accelerate to the right. So that's what they're saying. But I've also given us the acceleration with which the 10 kg block is going to move to the right. So what is that acceleration? They're saying that acceleration is equal to 1.2 meters per second squared. So does this acceleration apply only to the 10 kg block? No. It also applies to the 2 kg block, because they're all accelerating at the same time. It's a system, okay? So let me try to write this with a pen, because the pencil looks a little bit bad. So acceleration is equal to 1.2 meters per second squared, and this acceleration applies to both the 10 kg and the 2 kg blocks. Although they say that the 10 kg block is going to accelerate at an acceleration 1.2 meters per second, it doesn't mean that the acceleration of 2 kg block is going to be different. They have the same acceleration because they are a system. All right, so I hope that is clear. So 2.3 says, draw a free body diagram for the 2 kg block when the 50 Newton is applied to it. Okay, so let us look at the 2 kg block. So this 2 kg block is suspended. That means it is not actually lying on a surface. It means that there is no horizontal forces that are acting on this 2 kg block. Only the vertical forces are acting on it. But how many vertical forces are acting on this 2 kg block, and what are those? So let us look at this 2 kg block that is suspended. So of course we know that one force that is going to be acting on this 2 kg block is obviously the tension. So it is obviously the tension that's going to be acting on this block here, right? So a tension is going to be applied on this 2 kg block, and it's going to be applied due to the 10 kg block. So we have the tension acting upward. But of course, obviously, we also have the weight that is going to be acting downward. Everybody in this world experiences weight, or experiences the gravitational force. So that means this block is also going to experience the gravitational force. So we're going to have the gravitational force acting downward on this 2 kg block. So far we have 2 forces. But these are not the only forces that are going to be acting on the 2 kg block. We also have this force that have been given. We also have this applied force here, right, which is 50 newtons. That means besides the weight or the gravitational force, we also have the force applied that is going to be acting downward. So it means we have 2 forces that are going to be acting downward, and 1 force that is going to be acting upward. We have 3 forces. So that is actually enough, because the mark location is 3. So it makes sense that there are 3 forces and the mark location is 3. So let us show the free body diagram 2.3. So 2.3, the free body diagram of this 2 kg block looks like this. So of course we're going to represent this block by a dot, because this is a free body diagram, and we have the vertical forces only. So we have the tension force that is acting upward, so we're going to be like T right there, and then we have the weight that is acting, or the gravitational force that is acting downward, but we also have the force applied. So we also have the force applied that is acting downward. Now we have 1, 2, 3 forces. So this is how you draw your free body diagram. Certain people, I think like it is weird, but certain people actually draw it the same way, just that they do this. They say this is the weight or the gravitational force, and then they also do this. I don't like this, but you're also welcome to do it if that works for you. Okay, so if you're used to this, or if this works for you, then you're welcome to also do this, but I just prefer this one. So these 2 things means the same thing. You also want to be given full marks when you draw this one. Let us go to the next question. The next question, which is 2.4, says, I don't usually have enough space, so let me actually go to the next page to answer the next questions. All right, so far we have answered 2.1 to 2.3. So 2.4 is asking for, let us actually read it, calculate the coefficient of kinetic friction between the 10 kg block and the surface of the table. So they want the coefficient of the kinetic friction. So this is what they are looking for. So they're looking for the coefficient of the kinetic friction. So this is an unknown. So since this is an unknown, we're going to require a formula that has this unknown in it for us to be able to calculate it. So we have a formula at the back of the paper or in the formula sheet that is written Fk, which is the kinetic frictional force, is equal to the coefficient of the kinetic friction multiplied by the normal force. Right. So we're going to somewhat utilize this formula to calculate for the coefficient. So it means we're going to need the normal force and the frictional force. Okay, so this is our homework. For us to be able to calculate the coefficient, then we have to determine the kinetic frictional force and the normal force. That is our homework. This is our responsibility. Our responsibility is to determine the frictional force, kinetic frictional force, and the normal force. Okay, so we have to keep that in mind. So that means our homework is number 1, determining the kinetic frictional force, and number 2 is determining the normal force. After determining the 2, we're going to substitute them here, and then we're going to find the kinetic friction, the coefficient of the kinetic frictional force. In fact, what we can do already is the following. We can actually already divide both sides by n, or the normal force, so that we have the coefficient of the kinetic friction is equal to, dividing both sides by normal force, we're going to have the frictional force divided by the normal force. It means that the coefficient of the kinetic friction is equal to the frictional force divided by the normal force. So that after determining the frictional force and the normal force, we'll actually just substitute them and find the coefficient of the kinetic frictional force. So this is our homework. Right. So the question is, how are we going to be able to determine the frictional force and the normal force? Right. So they're saying calculate the coefficient of the kinetic frictional force between the 10 kg block and the surface. So we want the coefficient of the kinetic frictional force of the 10 kg block. So we want the coefficient of the kinetic frictional force of the 10 kg block. It means we're going to need to find, well, this is not really that much visible. So let me show you utilize a pen for that. So we have to determine the coefficient of the kinetic frictional force for this. That means we also need to determine the kinetic frictional force for the 10 kg block. This is our number 1 homework. Then this is our final homework. The number 2 homework for this is the normal force. This is our homework number 2. So these are the things that we have to determine for the 10 kg block. So how are we going to be able to do that? So we're going to be able to do that by the help of the 10 kg block. Because this is a system, we must not neglect the 2 kg block. So what you're going to do is we're going to consider the 10 kg block, all the forces that are acting on a 10 kg block, and all the forces that are acting on a 2 kg block. So far we know that there's 3 forces that are acting on a 2 kg block, and they are the tension, force applied, and the weight, or the gravitational force, right? So what are the forces that are acting on a 10 kg block? That means we have to draw the free body diagram for the 10 kg block. Let me actually shift it a little bit to the left, and then draw the free body diagram of the 10 kg block up there. So the free body diagram for the 10 kg block is the following. Right. So we're going to have the tension force that is going to pull the 10 kg block to the right, which is going to cause it to accelerate. So it means that the tension force is the largest force. It is the largest force because it is the one that is going to cause the 10 kg block to accelerate. So I'm going to draw a larger or a longer line initially. So this is the tension force that is going to cause the 10 kg block to move to the right. And we're also going to have the frictional force, of course, that is less than the tension force. So I'm going to draw a shorter line for the FK, or the kinetic frictional force. But we're also going to have the gravitational force that is going to be acting on a 10 kg block, and of course the normal force. So the normal force and the weight are the vertical forces that are acting on a 10 kg block, and they're balanced. Why are they balanced? Why are they still balanced even though the system is no longer stationary? It is because the system is moving, or well, the 10 kg block is moving horizontally, not vertically. So it means that the vertical forces are doing no effect on the motion of the 10 kg block. That is also explicable utilizing the work, energy, and power. So the normal force and the weight are acting at right angles. So they are acting at a perpendicular to the motion of the object. So the object is moving horizontally and they're acting vertically. So they're doing no work. Okay, we call that a no work when we are doing work, energy, and power. But since we're not actually doing that, we're just going to be like, since this is not actually moving vertically, this is moving horizontally, then the two forces are going to still be balanced. It means the normal force is equal to the weight. So let us actually write that down. The normal force is equal to weight. That means the normal force is equal to, since we know that the weight is equal to the mass multiplied by the gravitational acceleration, then we're going to be like the normal force is equal to mass multiplied by the gravitational acceleration. Why am I saying gravitation? Anyway, so this is what we know. We know that the vertical forces are balanced, right? Right. So it means that we can actually calculate the normal force of the 10 kg block. So we're going to have normal force of the 10 kg block is equal to the mass, which is 10, multiplied by the gravitational acceleration, which is 9.8. It means that the normal force of the 10 kg block is equal to 98 newtons. This N is for normal force. This N is for the symbol, or inertial symbol, the unit newtons. So it means that normal force is equal to 98 newtons. Now we have determined the normal force. So we have actually done the first part of the homework. So this is now complete. So the only thing that we have to determine now is the frictional force. So how are we going to be able to determine the frictional force? We're going to have to utilize the second law, the Newton's second law. So how does the Newton's second law get involved in this? It gets involved in the following way. They've told us about the acceleration. So the fact that the system is going to accelerate, then Newton's law is the only law that actually speaks about the acceleration. Right. So Newton's first law, Newton's third law, Newton's first law, and Newton's third law, they're not actually talking anything about acceleration. It is only the Newton's second law that is talking about the acceleration. Therefore, we're going to utilize the second law to help us to calculate whatever that we are going to be looking for, which is the frictional force. So the Newton's second law states that the net force acting on an object is directly proportional to acceleration, but inversely proportional to the mass of the object. So this is the formula for the Newton's second law. So this is the formula that we're going to utilize. So we're going to apply this formula, or this second law, on the 10 kg block and on the 2 kg block. Because although there is a system, the acceleration is going to apply both to the 10 kg and the 2 kg block separately, right? So we're going to be like, the net force on the 10 kg block is equal to the mass of the 10 kg block multiplied its acceleration. But they've also given us the acceleration, and they said that is equal to 1.2 meters per second squared. So we're going to apply the second law on the 10 kg block. Right, so we're going to be like, okay, the forces that are acting on a 10 kg block that are causing it to accelerate are the horizontal forces, because it is moving horizontally. So we're going to consider only these two forces, the tension and the kinetic frictional force. Since the tension is the one that is greater, causing the 10 kg block to move to the right, then we're going to write it first. So we're going to consider positive. And then, since this is actually the net force, we're going to have to say plus, because we are finding the total effect, or the sum, right? But we're going to be like negative frictional force, because it is acting in an opposite direction of the tension. So they must not have the same sign. Tension is positive, therefore frictional force must be negative. So we're going to be like T plus then minus Fk, which is equal to 10 kg. So the mass is 10 multiplied by acceleration, which is 1.2 meters per second squared. Right. So we don't know what the tension is equal to. So we're going to like tension minus the frictional force. So tension minus the frictional force is equal to 10 multiplied by 1.2 is 12. What we are looking for is the frictional force. But what I'm going to do is make T the subject of the formula. Why? Because the tension applies both to the 10 kg block and the 2 kg block. But the frictional force does not apply to the 2 kg block because the 2 kg block is suspended. It does not experience any friction. So instead of actually making Fk the subject of the formula, I'm going to make the T subject of the formula because T also applies to a 2 kg block. That is going to be center force, right? So we're going to the tension is equal to, then take the Fk to the right hand side is going to become positive. So we're going to have 12 plus the Fk. So this is going to be equation number 1. And then we're going to do the very same thing for the 2 kg block, and we're going to be like the net force of the 2 kg block is equal to its mass multiplied by its acceleration. So we're doing this for the 2 kg block. So we're going to be like the net force on the 2 kg block is going to be due to the 3 forces, which are the weight, the force applied, and the tension. So we're going to be like, okay, let us start with the weight first. So we're going to be like the weight, which is equal to, what is it equal to? It is equal to mass multiplied by gravitational acceleration. So we're going to be like mass multiplied by the gravitational acceleration. This is weight, by the way. So weight is acting downward, but there's also the force applied acting downward. So they're both going to be positive because now I'm going to assume we're taking down is positive. We're going to be like plus, but the tension is acting in the opposite direction, it's acting upward. So we're going to like be negative T. So this is going to be equal to the mass, which is 2 multiplied by acceleration, which is 1.2. Then we're going to just substitute and solve for T, or make T the subject of the formula. So we're going to be like mass multiplied by acceleration is equal to mass, which is 2 multiplied by acceleration, which is 9.8, plus the force applied, which they say that is equal to 15 newtons, right? So they've given us that the force applied is 15 newtons. Then we're going to the plus multiplied by negative is negative. Then tension is equal to 2 multiplied by 1.4 is 2.4. So the only unknown here is tension, fortunately. So we're going to determine the tension and then substitute it here and then solve for the Fk. Right. So we're going to the 2 multiplied by 9.8. Well, 2 multiplied by 9.8 plus 15, what is it equal to? Let me actually do this manually. So 9.8 multiplied by 2 is 19.6. So this plus 15 is going to be 34.6. So it's going to be 34.6. So we're going to have 34.6 minus tension is equal to 2.4, right? And then we're going to take the tension to the right hand side and then the 2.4 to the left hand side. So we're going to have 34.6 minus 2.4 is equal to the tension. Then the tension is going to be equal to the difference of this. So 34.6 minus 2.4, what is it going to be equal to? It's going to be equal to 32.2 newtons. So this is the tension. The tension is equal to 32.2 newtons. Now that we have determined the tension, we're going to substitute it there and then solve for the frictional force. So let us do that. So we're going to be like, well, the tension is equal to, let me actually erase this. The tension is equal to 32.2 newtons, which is equal to 12 plus the frictional force. So we're going to take the 12 to the left hand side, so we're going to minus it. So 32.2 minus the 12 is equal to the kinetic frictional force. It means the kinetic frictional force is equal to 32.2 minus 12. What is it equal to? It is equal to 20.2 newtons. So it means the kinetic frictional force is equal to 20.2 newtons. Now we have determined both the kinetic frictional force and the normal force. So the normal force is 98 newtons and the kinetic frictional force is 20.2 newtons. So what is going to be the coefficient? The coefficient, we said that it is equal to, where is it at? The coefficient is equal to the frictional force divided by the normal force. So it means that the coefficient is going to be equal to the kinetic frictional force, which is 20.2 newtons divided by the normal force, which is equal to 98 newtons. So what is this equal to? So 20.2 newtons divided by 98 newtons is equal to 0.206, which is equal to 0.21 to 2 decimal places. So it means that the coefficient is equal to 0.21. Okay, so the coefficient of the kinetic friction is equal to 0.21, and this is how we get our 7 marks. So a lot of learners are actually intimidated more by the mark allocation than the question. So do not be one of those learners. Try to tackle the question and utilize all the concepts or all the theory that you have actually learned and all the information that you have actually been provided with to calculate what they're going to be looking for from you. Okay. So let us go to the next question, which is 2.5. So let me shift a little bit down so that you can be able to see how I'm going to answer the next questions. All right. So 2.5. They're saying to us, how does the value calculated in question 2.4 compare with the value of the coefficient of static friction for the 10 kg block and the table? Write down only larger than, smaller than, or equal to. I said in the previous video, well, what they're saying is the coefficient of the kinetic friction force, which we have calculated to be 0.21. How does it compare to the coefficient of the static friction force? I explained in the previous video that the coefficient of the static friction force is always greater than the coefficient of the kinetic friction force. This is always the case. The coefficient of the static frictional force is always greater than the coefficient of the kinetic frictional force because the static frictional force is greater than the kinetic frictional force. Because this is the case, then that is also the case. So this is always something that applies, okay? But so we're going to write greater than or larger than. Yeah, so we're going to write larger than. So let me actually write the answer first. This is greater than this. So the answer is going to be larger than. So if you want to know why is that the case, then think of this. So we have this, I guess, the 10 kg block. It is on the surface of the table, so it is rough, of course. So the static frictional force is the force that denies the motion of the 10 kg block. It means the 10 kg block is stationary. It is not yet moving, or it is not yet started to move, right? So the force that actually causes the 10 kg block not to move is the static frictional force. But the force which denies the motion of a moving 10 kg block is the kinetic frictional force. So with the kinetic frictional force, the 10 kg block is moving, although the frictional force is acting on it. So we call it kinetic because the 10 kg block will be moving. That force is less than the one that is going to keep the 10 kg block at rest. So the one that is keeping 10 kg block at rest is stronger than the one that is going to be denying the 10 kg block while it's already in motion. So of course the kinetic frictional force is denying the motion of the 10 kg block, but still the 10 kg block is moving. It is not really stopping it. It is denying its motion. So it is trying to resist it from moving, but the 10 kg block is still persisting to move. But with the static frictional force, it is really denying its motion. That is why it keeps it at rest or stationary. So I hope that is clear. Right, so the last question, which is 2.6, says, if the 10 kg block had a larger surface area in contact with the surface of the table, how would this affect the coefficient of the kinetic friction calculated in 2.4? Assume that the rest of the system remains unchanged. Okay, so write down increases, decreases, or remain the same. Give a reason for your answer. Okay, so they're saying that the surface area in which this the 10 kg block is on increases. So the type of material does not change. The only thing, this is something that you should know, the only thing that affects, let me actually write that down. Maybe you're going to need to write this into your notes. The only thing that affects or has an influence on the frictional force is a type of material that an object may be on. For example, wood, paper, metal, you know what I'm saying, and stuff like that. All right, so these are different materials. So these are the only things that affect the frictional force that is going to be acting on an object on that surface. So if the type of material is not changed, it means the frictional force is not going to change. Therefore, the coefficient of the frictional force is also not going to change. So the fact that they've only increased the surface area, they have not changed the type of material, it means that the coefficient of the, therefore it means that the coefficient of the frictional force is going to remain the same. The only thing that affects the frictional force, whether it is a static frictional force or kinetic frictional force, is a type of material. So if a type of material is not changed, it means the frictional force is also not going to change, or it's not going to be influenced. So whatever that happens to the frictional force happens to its coefficient. So it means that since the surface area is being increased and not the type of surface, then the frictional force is going to remain the same. Thus, the coefficient of the kinetic friction is also going to remain the same. So it means that the answer for 2.6 is remain the same. And the answer is the one that I've written here. Okay, so I've already written the answer. I just have to write I just have to write remain the same. So the answer is remain the same. So the answer is remain the same, and this is the reason. The reason is the only thing that affects or has an influence on the frictional force is a type of material that an object may be on, not the surface area. So the surface area does not, or you can also say the surface area, we can say the surface area doesn't affect frictional force. Thus it won't have an effect on the coefficient of the kinetic friction. So you can either write this reason or this one. By the way, this is just going to be in 2 lines. So you're going to write remain the same and this reason, which is just going to be in 2 lines. Okay, so it's not going to be as long as it looks here. So this is how we answer this typical question from a previous question paper. So I hope that you have enjoyed and you have actually understood. I hope that this has actually made a difference in your knowledge regarding physical sciences, and this is going to be helpful. Anytime you're going to need to refer to Newton's laws, please come back to this video or the previous one. So we're still going to be doing Newton's law. This is the second example, and the next video is going to be the third example. Ciao. See you in the next video.